with presentation from Ohryn Valecourt. Ohryn has been serving as the managing partner and operations manager of Mid-Atlantic Microbials since 2018, collaborating closely with his wife, Jewel Valcourt. Their shared passion lies in advancing the understandings of the intricate science behind soil microbiomes and utilizing this knowledge to accelerate the process of soil restoration. Fantastic. Okay, welcome, Ryan.
Good morning, everyone. I'm very, very excited to be here. Thank you for the wonderful introduction. So here at Mid-Atlantic Microbials, we, as you learned in the first session from Dr. Elaine Ingham, we are a soil microbiology amendment company that does not only soil amendment, compost, but we also do liquids. So in a nutshell, I want to share with you all some of the things that we have done here in the Mid-Atlantic region, mostly all here on the eastern shore of Maryland. Slide. So I'm going to do a few comparisons. So right here we have a row crop farmer, not from our area, but a project that we had done quite a while ago. And this was done with our dry soil amendment. And as you can see in this photograph, the standard conventional practices are on the left. That's a 65 bushel an acre standard for this particular farmer. The soil amendment that we used, and this was a one-time application, had a significant increase in yield up to 97 bushels an acre. So you could imagine that the farmer was very, very happy with that. And when you look at the comparison of the plants and the plant material, you'll see that the soil amendment only treated side there is much more dense in its foliage and of course the food production. And when you're growing in a healthy soil system, as you learned in session 1 from Dr. Elaine, who is one of our science advisors since the very beginning of this company, you get a much healthier plant that is resistant and needs no pesticides or herbicides. In addition to that, the nutrient density of the food being produced here, in this case it's soybeans, is dramatically increased. So when you get to the situation of food insecurity, which we're all very aware of, having plants that are growing in this type of environment, you're going to remain a much higher nutrient density, and the microbiome of our body is a mirror of the microbiome of the soil. So you're going to absorb a lot more of the nutrients and you have to eat a lot less food. So I just wanted to make that point right here at the very beginning. Next slide, please. So here is our St. Paul's church restoration, and this was a stream bed area. Slide, please. Now they used spent mushroom soil on this site, and you can see right here that spent mushroom soil has been put down. Next slide. So this is 2 weeks after. You can see how the grass is taking off. Next slide. And this is a picture of the control area. So you see where there's no germination happening is where they just had the spent mushroom soil and seeded it. The area where you see all the grasses growing is where we treated it. So on this site, we used not only our dry application, which is our soil amendment, but we also used liquid extract. So doing a liquid extract requires us to strip the biology into a liquid form and then deploy that. Our recommendation to farmers or restoration projects is 16 to 20 gallons an acre. Next slide. So this is more of a close-up. So you see the before and the after, and in 2 weeks you can see how dense the germination was, and that is coming into a grass maturity. Next slide. This is Tuckahoe State Park. This was an agricultural site that was being returned back to nature. Next slide. So it's a little difficult to see the control in this picture where there was no treatment. And the treated area has a much denser foliage and germination rate. Next slide. So this is a close-up of the control, and you can see that there's some indigenous weed, some bare areas. And when you look at the treated side, you can see how much denser the germination is, and this is weed-free. Next slide. So this is a project that we did at Camp Pacomath, and this is the stabilization of a eroding beachfront. Next slide. So we came into this project after they had already put the grass plugs down. We came in after it was done and then had to amend each one of those areas. So you can see that beginning of that on the slide to the right, the December 20th slide. Next slide. So here you can see 6 days after application on December 26th that we're getting germination in 6 days. And this was in December, so not ideal conditions for germination. And then the companion picture here, 10 days after application, you can see that it is absolutely starting to take hold. So this is 5 months after, and you can see that the treated area is now really starting to establish, and realizing this was winter, so things are a little bit slower to establish. And then the south end here, where we did no treatment, our control area, you can see how sparse that is, and it's just barely getting going. So this is Caroline County Parks and Recreation. This is a wildflower restoration, is the part that we did here. This is a private-public partnership. We worked with all the engineers to do this berm. Next slide. So on October 28th, you can see this was right after seeding, and they had put down the hay there. They had used on this site topsoil that they had stripped, and the topsoil, after we looked at it under the microscope, was not very robust topsoil. So you can see on 18 days later, after we did our liquid application, we were discharging our hoses, and you can see that it left like a hieroglyphic behind. Next slide. This was before our liquid application, and our soil amendment and compost was mixed in to this berm site. So this is 18 days after, and these are areas where we applied. You can see that it's still a bit rutted up. They used some, heavy equipment to create these. And so there's some compaction areas. So anywhere where you don't see it germinating really well, it was a bit compacted from the tracks of their equipment. So this is another Caroline County site that we did, and this is an example of athletic fields. So what we did here was we put down our dry amendment, and then we went over it with a liquid treatment. And you can see that with one of our partners, Todd Higgs, is pulling the tank while we were spraying that. So this was a very unique situation. They were thinking of spending over $100,000 to put down new sod. And I told them, I said, look, let's go ahead and see if you aerate the field. We put down our dry amendment, and then we come do some liquid treatments. Let's see if we can bring these fields back to life. So this is what we saw under the microscope. So the control sample is pretty indicative to the Eastern Shore. It is got a lot of sand, silica there in the sample. It's bacterial dominated. You don't see any fungal hyphae. It's in very poor condition. The two treatment side, that's after our second liquid treatment, after our dry went down. And you can see this is much more robust. The system is coming alive. There's fungal hyphae in here now. You've got the majority of all the good guys you want in the bacterial and fungal. We also found the nematodes, the micro and macro orthopods, all on this site after our second treatment. And this was only 3 months, 3 months in. Next slide. Here we have Mason's Farm. That's Bill Mason started this as an organic farm, and Steve, his son-in-law, who had brought us in several years ago, and we have treated around 250 acres there in different test areas over these last years. We've done the majority of it has been done with our liquids only. One real interesting thing here at Mason Farms is that we were able to deploy our liquids through their overhead pivot. And that was that's a 100-acre pivot that they had. So we can deploy in large scale on large farms to get the biology down in a drench. And we also do foliar applications in the event that there is a pest infestation that is recognized. We can create a foliar spray also. Next slide. So we've done the dry amendments, 2 liquid amendments, and we also have quite a bit of microscopy work that we've done here to track how this is going. Next slide. So here we have the before and after microscope imaging. The control sample you can see is pretty similar to the one we looked at earlier. It's pretty much full of silica. Yeah, it's sandy soil, bacterial dominated. And then the 3 treatment sample is where we're really building soil structure. This is now about 18 months in, and we have fungal hyphae. We've got the nematodes, micro macro orthopods. It's coming close to being a balanced soil system. Really beautiful work over there at this organic farm. So questions from anyone? Happy to answer any questions. Thank you.
Thank you, Ohryn. Wow, really wonderful. pictures that speak 1,000 words. So thank you so much for that. So we do have a couple of questions for you, but before we get to the questions, we're happy to let you know we have a surprise guest today. And you might recall last conference when we had Steve Kraszewski from Mason's Farm, which is Maryland's largest organic grain operation. And Steve gave us a presentation on his farm's adoption of organic regenerative practices, and it was really wonderful. So great to see this partnership and the team between Orion and Steve, but great to have Steve back this year. And Steve, we're just going to give you a couple minutes to give us a quick update about things happening on your farm.
Very good, Greg. Thank you for that introduction. And yeah, the relationship between Mid-Atlantic Microbials and, of course, Orion, you know, kind of started with that partnership, as you'd mentioned, based on the same, I guess, the same philosophy, which is kind of improving from the ground up the soil, or as I think Elaine and Adam's presentation from the beginning of the month, the first session, converting dirt into soil, or using that similar analogy. And we were just needing a change here on the farm, and we were able to, yes, get in contact with Orion and the company. And what made it very helpful for us, especially on the farm at any time, they can do those assays or microscopies in real time. Come on the farm, grab the sample, they take it back to the lab, to their lab, analyze it, and put together a custom tea or drench with the proper microbial, the organisms, and have something available to you in the next several days, or possibly even the next day. That was a very helpful thing for us. And so, yeah, analysis and the solution in real time, especially when we talk about soil health practices and regenerative farming, that's a big deal for us and anybody else who is using this kind of system. What the main thing I wanted to say about Mid-Atlantic Microbials, they're able to put those concepts and the science that you learned from Elaine's presentation last week, put those into practice and implement it on a large field scale. For example, as Ohryn mentioned in his presentation, using the center pivot, which is actually a 200-acre circular pivot irrigation system, and as simple as just hooking in some hoses and running it through as a drench on the acres that we want to. So yeah, that's an easy, quick way to scale up. And we also, from you noticed from last year, we can also apply it with a sprayer, and just like any of the other equipment that covers lots of area in very quick fashion, can be done quickly and easily. Liquids, easy to administer, and top dress your field, and so forth. So, but we've really seen some positive results from with these theories and claims. They can really back them up. Our strip till corn experiment went very well this year with the tea drench, and saw some better yield gains than any of the other types of products we put out in the row. So we're very happy to see that. And not only the end of the year with the yield, when the combine goes through and you get those numbers, but during the season, we could see improved drought tolerance when we had dry spells. Even though these fields are under irrigation, we noticed that we could let the irrigation go even longer if we chose to, without seeing the normal stress that we could from fields right next to it that didn't have any of the similar treatment that we're not currently experimenting with these teas and these microbial inoculants. So those were some very positive results that we were able to see. And yeah, it's all about building that robust, resilient, as I call it, a soil reservoir. That's what these products can do. It's just a given time and a plan. We just have to make sure that our management practices in the field match what we want to see. So reduce tillage has been our main goal, and with Orion's help and Mid-Atlantic Microbials and their product, and that's, we're on our way here at Mason's Heritage.
Fantastic, Steve. Thank you. So great to hear about your continued progress there and the scale at which you're able to demonstrate and use these practices. Really fascinating. Okay, well, we've got time for a couple of questions here. Probably back to Ohryn, just folks asking, could you say a little bit more about the formulation of both the dry and liquid application? What exactly is in those products?
Well, our dry amendment is derived from the massive excess of chicken litter. It doesn't need to, so we set up on chicken farms and we use that as our basically nitrogen base. We mix that in our proprietary blend that took us over 7 years to create with a hardwood chip that's coming from all the landscapers and so on. So yeah, these are inputs that are accessible, they're easy to get. We also have some green materials that wind up going in there, but because we're able to work with the microbes, we put that into a composting system that I don't want to go into because that'd take a little bit longer. And so this is all indigenously based. All the chickens are here on the Eastern Shore. The plant material that's coming in to create the compost is all indigenous. And I saw one question that said, do we do that? Yes, we mine the indigenous biology from the forest around the farm, like over Mason's farm. I took a couple buckets, 5-gallon buckets, took a walk in their woods, right? And we wound up creating some of our biology from exactly what is right in their field area. So does that answer the question?
Yeah, it sure does. Now, the wet formulation, is it just the same as dry, but in a slurry? Or what's the difference between dry and wet?
Okay, so what we do is we take our compost or amendment because we do amend our compost to create a really, really powerful immediate reaction. And so we strip that and in an aerated tank. So there's air bubbling up. And so it takes about 2 or 3 hours to extract all the biology. And then that can sit for a few hours or whatever. It's not in a rush to get it right out the door, but it has to go down within 24 hours. So we make it on farm or like at Steve's farm, we're really close. So we make it at in our brewers and then just run it over there in the morning and, he puts it out. So, yeah, very simple. We make these in batches of anywhere from 250 gallons to 1,000 gallons. As I said in my presentation, 16 to 20 gallons an acre is the application rate. And that is a drench. So a foliar application, it takes 16 to 24 hours. And then what we're doing is we're growing the biology species that we want in the tank. And then that's going to stick to the plant surface. So no need for pesticides or herbicides if you're doing a foliar, if you see something that you need to use a foliar for. We've not done that at Mason Farms yet.
Okay, all right. Wow, thank you. That helps us understand the formulation and what we've got in there. So yeah, unfortunately, there are many, many questions coming in. So much we'd like to ask you about. I'm going to just grab one here from the list as we conclude this discussion, and it's about cost. Where are we at cost? I could expect that we're at a smaller scale at this point, so maybe we haven't gotten all the benefits of scale yet, but do farmers have a cost-effective alternative here with managing their land yet, or are we still in a scale up to get that cost down?
Well, I'll make a quick comment on that. Our cost is $1.25 a gallon. So when you're putting down 20 gallons, comparatively to, and Steve can answer this question, to what a nitrogen product or any other organic fertilizer that they use there. So all our studies show that we are significantly lower cost. So Steve, any comment on that?
Yes, those numbers are right, Orion. So anywhere between, I think $30 and $40 an acre, depending on, yes, the rate we put down, which is about 20 gallons per acre. But in terms of what you get for your application, you're talking about, if you're putting down, say, poultry litter, that's one of our sources of nitrogen and other fertility. We put down, for at least for our corn, you're looking at a minimum of $100 per acre for every acre for your corn ground, just your corn ground. And so, even several applications of the product from Mid-Atlantic Microbials and what you're getting out of it, as long as you are managing your field the way, like I said, that you're trying to achieve your goals, as long as you're keeping your tillage down, that's probably the most important thing. As long as you're letting those trenches do their work, letting the soil be at rest, and watch your compaction and many, many other things along the way, it's seeming to bear fruit, and it's well worth the investment.
Wow, that sounds really encouraging. Okay, well, thank you.
I do want to make one comment real quickly, is that this hasn't been brought up that I know of, but the carbon sequestration level of a healthy soil environment is off the charts comparatively. So if when we're looking at global impact, if we can restore farmland, like we're doing, with Steve and others, and or recreational spaces, urban space, it doesn't matter. You're going to get a tremendous amount of carbon stored, and it's going to stay there for thousands of years. I mean, as long as it's an active microbial soil environment. So, yeah.
Okay.
Just wanted to get that last one in there.
Well, that's a big one. That is a big one, if that potential exists. Wow. Okay, great. Well, thanks again, Ohryn and Steve.